Hi folks, Harry Frank from Red Giant here, and in this series of tutorials, we're going to be talking all about Trapcode Form. Trapcode Form is a 3D particle system. Now, you may be familiar with traditional particle systems like Trapcode Particular. In Trapcode Particular, we have particles that are emitted or born from a certain point or area in space. They do something during their lifespan, like move and become affected by outside sources like gravity that pulls them downward, and then they come to an end of their life cycle and they die off. The first key thing to understand about Trapcode Form is that although it is made of 3D particles that exist in 3D space, those particles have no lifespan. They are always there. Also, there's no emitter. We don't have the ability to continuously emit particles. We just say how many particles we would like at any given time. So here's a good way to think about this. Trapcode Particular focuses on individual particles. How many particles per second, what the lifespan of each particle is, the velocity of each particle, that kind of thing. Trapcode Form focuses more on the group of particles. So how we affect the whole body of particles. And the result that we end up with is a very organic sort of group of particles that can be used for all types of fire and plasma and smoke kind of effects, and a lot of other things that simply require the use of static particles that have no beginning or end of their lifespan. So let's start with the basics and create sort of a very basic fractal influenced background that looks like this. We can integrate a logo and then integrate a feature called the spherical field that allows us to displace particles inside a spherical area. And inside there, we'll stick a logo. So let's close everything up and create a new composition. I'll work at 1280 by 720, and I'll make my comp duration 10 seconds. Now, when we're working with Trapcode Form, it is an effect. And like all effects in After Effects, they need to be applied to something. So I'm going to use a solid. So I'll go into Layer, New, Solid, and I'll call this Form. I want to make sure that this is the size of the composition. The color doesn't matter because that's simply going to go away. I'll click on OK, and then we'll go to Effect, Trapcode Form. That's also a good idea to create a camera. So I'll go to Layer, New, Camera. Form is 3D, so once we create our camera, I can hit C, toggle through the different options, and orbit around my particles in Trapcode Form. Let's zoom in just a little bit. Now, by default, we have a grid of particles. We have 3 separate grids. This grid is established in the base form. We have a base form that is a box grid. The size is 200 by 200 by 200 pixels. We have a square in X, Y, and Z. We have 70 particles in X and in Y. So if I set this to 20 and 20, we'll see a lot fewer particles on the individual grids. We see 3 grids because we have 3 particles in Z. So these are evenly divided along the size established in size Z. So we have 200 pixels in Z. If I set the particles in Z to a higher number, these will continue to be sized inside the size Z right here. For our example, we're simply going to use 1 particle in Z. So that's going to keep it centered right in the middle and give us 1 sheet of particles that is a box grid. Now, for a full screen background, we're going to want to make this box the size of our composition. So in my case, I'm going to type in 1280 by 720. At this point, the size Z doesn't matter because we only have 1 set of particles in Z, and it's always going to remain stuck right in the center. So to make something that looks like a cluster of particles like this, we're going to need a lot more particles. Now, we don't necessarily need a 1-to-1 representation of particles per pixels in our screen. So in other words, we don't want 1280 by 720 particles. This will be very costly in terms of the render time, and it really isn't going to do much good for you unless you're trying to get detailed images rendered by the particles. I would suggest staying something more like 300 and 200. So all we've seen so far are pretty static grids of particles, which aren't exactly that interesting. So let's make this look a lot more interesting. And to do that, I'm going to skip over a number of sections here and come down to the fractal field section. If you're going to be using form, you'll be using this fractal field section a lot. Well, so if it's so important, why is it about 5 steps down from where we started? Well, the thing to remember with form and most Trapcode products in general is that the interface is sorted in the order in which things are processed and calculated. So the first thing that we establish is where the points in space are by the base form. Then we establish what we actually render on those points in space with the particle section, and then how we shade those particles, and then how we affect those points in space from the top down. So we have different maps and disbursement and twisting and all that kind of stuff, and we'll get into all of that. But let's talk about the fractal field. Now, the fractal field is just like any traditional fractal noise generator that you might be accustomed to, just like the After Effects fractal noise effect. We have dark areas and light areas and everything in between. So we have large areas of noise and small areas of noise all laid on top of each other. And that's exactly what fractal noise is. We have layers of noise that start large and get smaller and smaller and smaller and then get mixed together in a certain way. That fractal noise map can be used to affect things like the size of the particles, the opacity of the particles, but more interestingly, we can affect the displacement or the positions of the particles. Now we're starting to look a little bit more interesting. So what's going on is we have dark areas and light areas, or low areas and high areas of this map that we can't really see, but we can see its effect on the particles. So personally, I think it's a great idea to really understand what is going on when we talk about a fractal field in a 3-dimensional fractal noise map, because there's some pretty detailed controls down here that get into the heart of what is going on with your fractal field. And if you don't understand what's going on, none of this stuff is going to make sense down here in the fractal field section. So let's talk a little bit about fractal noise structure. So I have a solid here, and I'm going to turn this on. This solid has the After Effects noise filter on it. It's set to 100%, and we have it using black and white noise. The scale of this is set to 6400%. So I've scaled it up quite a bit. And if we zoom in, we see that we've got large light areas and large dark areas, but not a lot of detail. So if I want more detail, what I can do is take an identical layer and lay it right on top, but scale it by half of the one prior. So if I turn that layer on, and notice I have this set to an add blending mode. So it's going to mix these together. So now I still have some dark areas, but now I have a little bit more detail added on top. Now, if I keep going and keep adding different layers, and I'm going to keep scaling each one down by a factor of 1/2. So 6400 to 3200 to 1600 to 800 to 400, 200, and then 100. There we go. And we end up with something that looks quite a bit like fractal noise. Now, if I take a look at the opacities of each of these, actually what I should do is say, I want my first layer at 100%. Let's do the same thing. We'll go down by 50, then 25, then 12.5, and then I'll start to approximate here. I'll go to 6, and then 3, and then 1.5. Well, it looks a lot like fractal noise, actually. So why do I bring this up? Why am I stacking all these layers of noise on top of each other? Well, like I mentioned, this is exactly how fractal noise is made up. And in fact, this is actually how we construct fractal noise. This is at the roots of what fractal noise is. And if you understand this, then you understand all of these controls down here, all of these elusive gamma and added, subtract, min, max, f scale. Well, actually, f scale we'll come back to. Complexity, octave multiplier, and octave scale. So first off, this one right here, complexity. This is the number of layers of noise that we have. So if I turn off all but 3, I have a complexity of 3. And you'll notice we don't have a whole lot of detail in the displacement of the particles. So we kind of see these bending areas that don't take a lot of quick twists and turns. They take very large, kind of flowing twists and turns, which I think feels pretty good. But if you wanted more detail in there, I could set this to, let's say, 5. And now we'll start to see a lot more detail. Maybe this could be something more like fire, where we have a tremendous amount of detail in here. But for our background, I think we'll stick with 3. But it's good to know what's going on with that complexity. Now, back up to the top here, we have gamma, add, subtract, min, and max. So if on our fractal noise layer, I were to add some sort of adjustment layer, and I apply color correction levels, I've got black point, gamma, and white point. So when I work with the black point, we're sort of establishing the black minimum of the values. Everything below that's getting crushed. So that's sort of like the minimum value. And the white point here would also be the maximum value. That would be the maximum of what value is being allowed by the levels. And right here in the center, we have a standard gamma control that pushes the midpoint of the luminance around. So if we go back to trapcode form here, we'll notice we have a gamma control. We have minimum and maximum, so we can establish sort of that clipping area of the black and the white areas. And we also have an add and subtract, which basically you could think of like something you probably don't use a whole lot, which would be brightness. We can take the whole thing. In fact, if I put the levels after that, we'll see this in the histogram. I can move the whole thing up and down. So we're adding or subtracting from the original values. So that's what all that does. Gamma, add, subtract, min, max, complexity. So what we haven't spoken about are F scale. This is just the overall fractal scale. So if I bring this down, it actually gets larger. And if I bring it up, the areas get smaller. So it's the overall fractal scale. So if I were to take all of these layers and select the scale values and change all of them at the same time, that would be the overall fractal scale. Related to that are octave multiplier and octave scale. You kind of already know what these do. We've spoken at length about scale and opacity from one layer to the next. That's exactly what these are. So we're talking about octaves, or the different layers of noise and how they're stacked on top of each other. So we had different scales and different opacities. Octave scale is the difference in scale for each layer of noise. So for easy math, if I set this to 2, this is a factor of 2, or twice as much from one layer to the next. So actually, if we go from the top layer down, if we double each one, 1 to 200 to 400 to 800, that is a factor of, so the default setting of 1/2 is actually scaling each layer by 2/3. That's why I switched this over to 2 for easy math. So and again, an octave scale of 2 means each layer is double or half of the layer above or below it, depending on which way you're looking, from top to bottom or bottom to top. Similar to that is the octave multiplier. That's basically the opacity or overall visible influence of that layer. So a setting of 0.5 means that each layer of noise is scaled, let's get rid of this adjustment layer. Each layer is scaled half from the previous. So 100, 50, 25, 12, 0.5, etc., etc. So each layer is going to be half as visible as the prior one. But we can change that If I set the octave multiplier all the way down to 0, we've essentially gotten rid of all of the fractal noise layers except for the first one. Everything else is invisible except for the very first layer. So if I set this complexity up or down, even though it's calculating it, it's not actually doing anything. Let's put that back to 3. As long as the octave multiplier is less than 1, you will have a decreasing opacity value from the largest layer to the smallest layer. If I start to increase this, in fact, if I bring it over 1, what we're going to see is a shift to the smaller areas and less on the larger areas. So this is why we start to see lots of scribbles here, because we're basically looking at the more detailed areas and less at the larger areas. I think for the flowing organic look of Trapcode form, you're going to want to stick with an octave multiplier that is definitely less than 1. And maybe we'll bring this octave scale down as well. So we get this sort of nice, swooping, organic kind of look. So now you understand at the heart what's going on with the fractal field. Let's hit reset and do this again. But this time I'll do it quickly. Base form, set it to 1. Set my size in X and Y to be my size of my composition. I'll up the particles in X and Y. Go down to fractal field and set this to displace. I'll set this to 150 pixels. Now we do have the option to set the fractal field to displace in one axis only. So I could set it to just X or just Y or just in the Z. Or I can have it map it in a radial fashion, which basically goes from the center outward. I'm going to stick with XYZ linked, so they'll all move in all 3 axes. But I can have the fractal flow in a certain direction, so I can have it flow along the X or Y or Z. By default, there's also a flow evolution turned on. So this setting of 50 basically means that the fractal noise is evolving over time, exactly like the evolution setting in a standard fractal noise control. Now, a very handy feature is this flow loop checkbox. So in the case of making a looping background, I can set this loop time to be the duration of my composition, which is 10 seconds. And then as the playback comes to the end and loops back around to the beginning, you'll notice that we have a seamless loop. Be careful, because you can set your loop time to be smaller than what is mathematically possible with a looping fractal. Now, Trapcode form will let you know exactly when that happens. The way you're going to make that happen is by setting both your flow and flow evolution to values that are too slow to allow it to happen in the time that you have specified. So if I set these both to very low numbers, we're going to have an error saying that we cannot construct a loop because the time is too short with current flow speeds, and it tells you exactly what to do. And in fact, it'll estimate how long your composition length would have to be to have a loop at the speed that you've specified. We've set these very low, so the composition would have to be 35 seconds long. So let me set this back to 50, and the flow evolution can also be 50. So I think I've covered everything in here except for one little pop-up right here, which is fairly simple. Our fractal sum right now is noise. That is a black to white noise and everything in between. When we're talking about displacement of particles, anything set to gray is neutral. It doesn't push it one way or the other. Now, in a map that goes from dark values to that 50% gray to white values, it will push it in all different directions. So if I set the fractal sum to this ABS, which is an absolute value, which basically means that the values never go negative. Or if we think of that 50% gray as that neutral point, values of the fractal noise map will never go below that 50% gray. If they go below, they are remapped and flipped upside down. So instead of going from gray to black, that value is inverted and gray to black becomes gray to white. So that's why we see a lot of the particle displacement moving in the same direction, because that fractal noise map is sort of repeating twice as much. Now, the practical application of this is on surfaces that are on fire, or perhaps even water surfaces behave like this. I'm going to leave this on standard noise. So onto this logo that we're going to construct. So you notice I had some color in this. So let's talk about how to add color to our particles. Now, one way to do this is to go to the particle section and change how the particles look. By default, particles are white, and I could set them to red. But basically what we're going to be doing is setting all of our particles to red. And that's not exactly what we want to do. So that's not really what we want to do. You notice this one is kind of red on the edges and then kind of a lighter gray on the inside, matching the colors of this logo. So to do that, we have to create a color map. And there's a couple different ways we can do this. So let's skip over this shading section and talk about quick maps. Quick maps are a very powerful way to control how your particles behave in a number of different ways. Quick maps can map any number of things. We have color map, which is the very first set of quick maps, and then we have other parameters like size, opacity, fractal strength, all that kind of stuff, and we'll get into that. But right now we're going to talk about color maps. I need to open this up just a little bit more. We can create a map that's contained within the plugin and doesn't use any external layers, and apply those maps to different parameters like opacity and color. So let's say I use a map like this that has a value of a high value on one side and a lower value on the other. I'm going to map that opacity and color map right now, which is this spectrum map, over the x-axis. And as you can see, we have red to yellow to green to blue over here on the other side. Now it trails off because we have an opacity map that looks like this. It goes from high to low. So let's use a little bit more interesting of a map. Let's set it to this one right here. Let's set the opacity map so that it does not affect anything along the x-axis. And maybe we could add a little bit more density here by pushing the particles up to 400 by 300. Now, you'll notice that as particles overlap, they start to have their colors blending together. And this is a default setting. In the particle section, the particles, when they overlap, they're using a blending mode of add. If I set this to normal, we'll see a much flatter kind of look. I can also set it to screen or lighten, but add I think is just fine. So the idea of the quick maps introduces a very important concept in Trapcode form, and that is the idea of mixing a three-dimensional particle system with maps that are not three-dimensional. The maps that we are creating here are essentially one-dimensional, so we have a linear set of values that change over the course of one axis. So when we map these, we have to pick one axis to map these to. So if I set this to Y, it's going to take those values and map them from the top down to the bottom along the Y-axis. If I set this to Z, not a whole lot's going to happen right now because we only have one set of particles in the Z-axis. So in the case of a logo, I'm probably going to want some sort of custom value. So I'm going to copy and paste this logo into my composition right here, and it's got a little animation on it that we'll work with. So I'd like to introduce these colors of my logo into the colors of my form map. There's only two colors that I have in this logo, so this map only needs to have two colors. So if I click and hold and then pull down, I can start to pull out color points on this map. I'll double click on this yellow right here and I can select a different color. I can manually dial it in, or I can use the color picker to eyedrop the exact color right off of that logo. I'll do the same with this color right here and use an eyedropper to get that exact red and gray. So I mentioned we have X, Y, and just like we saw before, we have a radial map that maps from the inside to the out. So I'm actually going to flip these around so I've got the gray on the inside and the red on the outside. So moving on from the quick maps, let's jump down to the spherical field section. There are two spherical areas that we can specify where particles can be pushed or pulled towards the center or away from the center of a spherical area. So the first thing I'm going to do is click on Visualize Field. So as you can see, we have a spherical area that is represented in X, Y, and Z. What I'm going to do is turn up that strength to 100, and any particles that are inside that area are going to be pushed away from that sphere. If I set it to -100, they'll be pulled towards the center of the sphere. More often than not, I use a positive value to move particles out of the way. I can increase the radius of this and move it around in space. Now in this case, I'd like this spherical area to be exactly where the logo is because the logo is moving, and I'd like to displace the particles right along with it. So in this case, I'll simply link the position X, Y, and Z to the position X, Y, and Z of my logo. So I'll do this with a simple expression. So I'll hold down Alt or Option and click on the stopwatch of position X, Y and position Z. And it's waiting for me to create some sort of expression in here. So all I need to do is pick whip position X, Y to the logo position, and it's actually going to just grab the X and Y values, which is exactly what it needs to do. And then here in position Z, I can simply target the Z value, and it's going to grab that Z value from the logo. So let's turn up the radius. And turn off Visualize Field. Now we have a little bit of evolution going on here, but I think it should sort of be flowing from one side to the other. I like the idea of it flowing from right to left, the fractal field. So I'll go back into the fractal field section, and I'll set this to -150. Now, when originally implemented, the spherical area was always limited to a perfect sphere. And that's why it's called a spherical area. But now we can actually distort this sphere so that it's not perfectly spherical. So if you'd like it to be not quite an exact sphere, you can distort it in one way or the other and also rotate it in different axes. Now there's also a feathering control that feathers the influence area of the sphere. So if I set this to 0, we're basically going to have a hard-edged sphere that pushes the particles away. If I set this to a higher area, it's sort of a fuzzier area in which the particles are displaced. Now, I think we're pretty close. I think in terms of the aesthetic here, the fractal field is perhaps a little bit large. So I'll go to the fractal field and take this fractal scale down, maybe down to about 7. And let's raise that particle count up to about 800 by 600 to smooth it out a little bit. And then in the particle section, remember these are overlapping. We've added more particles. We have more particles overlapping, more particles blending their colors together. So once they start to get a little bit hot like that, I think it's a good idea to start bringing your particle opacity down, maybe even to 25%. That about wraps it up for this lesson. In the next lesson, we'll talk a lot more about this particle section right here and all the different particle types that we have available to us. So I'll see you in the next lesson.